In this problem, we're told in a grocery store, you push a 15.4 kilogram shopping cart horizontally with a force of 13.4 newtons. If the cart starts at rest, how far does it move in 2.5 seconds? So the first thing you always want to do is draw what's going on. So we have this guy, right? He's going to be pushing this cart with a force of 13.4 newtons. We know the mass of the cart is 15.4 kilograms, and we also know it's going to be starting at rest. And so he's going to push it for 2.5 seconds, and then it's going to reach some point, right? And so what we're trying to do is find how far the distance it travels, right? So we're trying to find delta x, essentially. So we're trying to find the distance it travels in these 2.5 seconds. So the way we're going to solve this is like a kinematic problem, and you'll see why. So what we want to do is write down the given. So what information are we told in terms of kinematics, right? So we know the initial velocity is going to be 0 meters per second. We know the cart is going to be pushed for 2.5 seconds, so t equals 2.5 seconds. And then what we want to find is the acceleration, because if we have the acceleration, what we're going to do is be able to solve for delta x, right? So notice we have v sub 0, we have t, and we're trying to find delta x. So if we can find one more variable, which is what we're going to find is a, based on the information they give us, which is the force and the mass, what we can do is, since we have 3 of the variables, we can go ahead and solve for delta x. So what we need to do first is find the acceleration. So how do we do that? So we find acceleration using Newton's second law. So we know force equals mass times acceleration. And more specifically, it's the sum of the forces in a direction, essentially. So we would say the sum of the forces in the x direction in this case, since we're moving it in the x direction, is equal to mass times the acceleration. So what are the forces in the x direction? So there's only going to be one force in the x direction, which is the force that the person's going to be applying on it. Meaning ma is going to be equal to 13.4, right? The sum of the forces is just 13.4. So what you should notice is ma, right? If we divide both sides by m, we can solve for the acceleration of our cart. So it's just going to be 13.4 newtons, and then you divide by the mass. And we know the mass of the cart is 15.4, and this is kilograms. So the acceleration is just going to be 13.4 divided by 15.4. And so when you do that, you're going to get a equals 0.87. So 0.87, and then the units are going to be meters per second squared. So now that we have the acceleration, right, we know it's 0.87 meters per second squared, we have 3 variables. So we can just go ahead and solve for delta x. So the equation we're going to use, you should be familiar with kinematics by now, but essentially delta x is equal to v sub 0 times t plus 1/2 at squared. And the reason we're using this one is because we know v sub 0, we know t, and we know a, right? So all we got to do is plug them in, and we can solve for delta x. So plugging it in, v sub 0 is 0. 0 times anything is still going to be 0. So we just have 1/2 times a, which is going to be 0.87, times t squared. So 2.5 squared. So what you want to do is plug this in. 0.5 times 0.87 times 2.5 squared. And so when you go ahead and do this, you're going to get delta x equals 2.71875. So I'm just going to round to 2.7. Just make sure you round however your teacher wants you to. And then this is distance, right? Delta x is change in position, so it's meters. So 2.7 meters, that's going to go ahead and be how far it travels in 2.5 seconds. So this right here is going to be your answer, and hopefully you found this useful.